Today we are going to use exponent rules to simplify, and the exponent rule we're going to be working on today is negative exponents, and then also looking at the exponent of 0. And so we're going to see the concept of negative exponents in the first example here. And so if I was to simplify this, typically when we're starting out simplifying, we would just write this out in an expanded form. Take 6 squared and write it out as 6 times 6. 6 to the fourth would just be 4 sixes being multiplied. And then I would cancel out the common 6's. And so I see that these 6's cancel out. And when I cancel something out, 6 divided by 6 makes 1. Do the same thing here. These 6's cancel out, and they make 1. Well, when I multiply the two 1's on top, I'm left just with 1 on top and a 6 to the second power on the bottom. Now, if I multiply that out, that'd be 1 over 36. Well, there's a rule that we talked about last year about this time when we dealt with exponents in 7th grade, and the rule is that we can subtract the exponents. Now, when we do this, though, we need to take away the bottom from the top, so it looks like this. 6 to the 2 minus 4, and then that is all on top of the fraction, so I'll treat this as a fraction so you can see that. And when I do that subtraction, I end up with a 6 to the negative second over 1. Now look at these two, they equal each other, and so notice that if you take the reciprocal, so you see how 6 to the negative second's on top? Well, if it moves to the bottom of the fraction, then the exponent changes to a positive and it becomes 6 to the second power. And that's the rule we're going to end up using. When we have negative exponents, we're going to take their reciprocal and then move them to one of the sides of the fraction that they're not on. So if they're on top, we'll move them to the bottom. If they were on the bottom, we move them to the top. And then they become positive exponents. And so we're going to use that rule, and then let's take a look at the next rule we'll see, and it's with the exponent of 0. So let's see what we get here. So let's go ahead and use that rule real quick. 6 to the second minus 4 is what we did here. Well, let's do the same thing on this one. Let's take away the exponents because we have the same base. And when I do that, I end up with x to the 0 power over 1. And that's the same thing as just x to the 0. Well, let's see what this represents if we write it out in that expanded form. So x to the second is x times x. And then same thing on the bottom, x to the second is x times x. So when we cancel out those common terms, we end up canceling out these x's and we get 1. Do the same thing on the next set of x's, and we get 1. And 1 times 1 is 1 over 1. Well, notice that the tops of these fractions are the same. X to the 0 will equal 1, and that's the key. No matter whether it were a negative number, and we'll see an instance like that, or if it were a positive number or any kind of number that we have, anything to the 0 power is just going to end up being 1. So let's take a look at this example here, letter C. And we have 3 to the negative third power. Well, we're going to use the rule with negative exponents. And so when we go ahead and do this, we'll treat this as a fraction. Write that as 3 to the negative third over 1, and let's just take the reciprocal. And when we do that, what we end up with is an answer with positive exponents. And now we can go ahead and multiply out those exponents. And we end up with 1 over 27. Well, we have the same scenario when we have negative exponents with a variable. Same sort of thing. Just write it as a fraction, and then take the reciprocal. Move those to the bottom of the fraction. This problem's even easier because there's nothing to multiply out. You just leave the answer as 1 over x to the second. Well, the problems can get a little tougher when there's more things involved. Here we have 3 parts to this term. We have got a coefficient and 2 different variables with different exponents. So treat that as a fraction. And then take a look at this. Y to the 0 power. Any number to the 0 power is just going to end up being 1. The only number that won't be is if it were 0 itself. So we can't do that one, but we can do any other number. It's just going to give us 1. And so here we have some negative exponents. And these will go down below, and then we'll have our answer. So we have 2 over x to the 5th power. And there is our answer, just like that. So, again, all you're going to do on these problems is just simplify it by getting rid of anything to the 0 power, and negative exponents, just take the reciprocal. So here again, treat this as a fraction. Anything to the 0 power, just going to be 1. Negative exponents only. So the common mistake is people see that -3 and they think, oh, well, I just need to take its reciprocal, it becomes positive. No, that's not the case. It's only the negative exponents that we take the reciprocal of. Any number that doesn't have the negative exponent just stays where it's at, stays -3. And now y to the 4th goes on the bottom. Well, we've got another scenario here with just some numbers. We're going to have to multiply these numbers out after we take the reciprocal. So first thing again is treat this as a fraction. If you don't see a fraction already, take those negative exponents and switch their location. Notice the -2 doesn't change. It's only the exponent that does. So here's the next rule we have to remember from way back in the beginning of the year. When we deal with exponents and negative numbers, this is the same thing as -2 times -2 times -2 times -2. And the reason is that we have the -2 in parentheses. So it'll be different if it's not, and we'll go over that next. Well, when we multiply an even number of negatives, we're going to get a positive. So that ends up equaling 1 over 64. And that would be our answer. So if they're just numbers, go ahead and multiply them out. Well, we have another scenario here. It looks very similar. The difference is, do you see the difference? We don't see parentheses around the -2. So this is something different. So this is the same thing as -1 being multiplied by 2 to the -4th. So this is the opposite of 2 to the -4th. And so the opposite means you need that -1 out front. Now, that -1 is not to the -4th power because it's not in parentheses. So it's just the 2 to the -4th that gets moved down below. Now, when you do that, it becomes -1 over 2 to the 4th power. When you multiply out all those 2's that we saw before, we get 16. But notice the answer is negative because we have that opposite of 2 to the -4th, and you'll see that on tonight's homework. So be very careful of this concept right here. So make sure you get that -1 being times by the number to that exponent, and then do multiplication last. So that's why it's a negative. Well, here's another scenario. We have the same sort of thing. Here we have another example of the opposite. So this is -1 being multiplied by 3 to the -2nd, and then times by -2 to the -3rd power. So we're going to take the reciprocal of just the negative exponent. So notice there are 3 numbers here, but only the reciprocal of the negative exponents go on the bottom. And so we still have that -1 on top. Down below we have 3 to the 2nd power, and it's being multiplied by -2 to the 3rd power. Well, when we go ahead and multiply that out, we end up with a -1, and then 3 to the 2nd makes 9, and -2 to the 3rd power. Now this is 3 negatives. Odd number of negatives makes a -8. So that makes -1 over -72, which just gives us a positive 1 over 72. Well, looking at the next one, a little different here because the negative exponents are on the bottom of the fraction this time. That's okay. All you have to do is take their reciprocal and they become positive. And so from that point there, we can go ahead and rewrite it as 3y to the positive 2nd. So again, when you move something to the other spot in the fraction, the sign will switch. So here it was negative. We move it up to the top, it becomes positive. So 3y to the 2nd. Well, 2 more problems. Taking a look at this one, we have more fractions to deal with. Now again, anytime we have negative exponents, that's what's going to switch locations in the fraction. So here, these negative exponents switch locations in the fraction. Notice these numbers will not change. They stay exactly where they're at. So keep that 2 where it's at. It doesn't have a negative exponent. Its exponent's positive 1. So that stays where it's at. So this is just 2y to the 4th power all over, and then here we have negative 3x to the 3rd power. So notice the only thing that changes is the negative exponents, the part with the negative exponents. So negative exponents and its base will switch. Well, here we have y to the negative 2nd. That's our negative exponent term, so that switches. Same thing here, c to the negative 1st. That will change. So what we have left here is a negative 5 on top. X to the 4th, that stays on top. Notice those did not change, especially that negative 5. That number does not change. And a common mistake is people like to move that because they see the negative sign, but it's only the negative exponents that we're going to end up switching. So we have that c to the, looks like the 1st power on top. And then down below, notice this, we have an a to the 0 power. Well, we could just cross that right off because any number to that 0 power is just going to end up being 1. And then all we're going to have down below is just that y to the 2nd. And there is our answer. So negative 5, x to the 4th, c to the 1st, or y to the 2nd is the answer. Good luck on tonight's homework.